investigating today is this. What is the ideal mechanical advantage, the actual mechanical advantage, and efficiency of a one-pulley system, a two-pulley system, a four-pulley system, and what happens to the efficiency of a pulley system as more pulleys are added? So right now I'd like you to write a hypothesis and answer that last question. What happens to the efficiency of a pulley system as more pulleys are added? Do you think the efficiency will increase? Do you think it will decrease? Or do you think it will remain the same? Okay, in our first pulley system, I want you guys to notice that what we've got there is a ring stand with a vertical support, and then we have a horizontal support on it. And then what you're going to do is you're going to take string, and you're going to tie it around the horizontal support. And you're going to loop the string underneath the pulley like this, and then the masses are actually hooked to the pulley, not to the string.
Look, weight's going up and down, measuring the force.
Okay, so the string is tied to the horizontal support, masses are hooked to the pulley, and then your force sensor is going to be connected here, and you're going to pull up for your first setup. For your second setup, if you look at the picture, you'll see again we've got ring stand and then horizontal support. And then in this one, we've got the pulley. The pulley is connected to the ring stand. The first pulley is. And then there's another pulley here. And the mass is connected to the bottom pulley. And the string, you start the string on the top pulley, wrap it around like that.
5.7 what? 5.7 centimeters. No, I mean, what is...
And then in your third setup, we're going to use what's called a block and tackle, which is multiple pulleys put together. Now the pulleys that I have available for you today are actually a little bit different than what's in the picture. They look like this. And what you're going to do again is hook up the masses to the bottom pulley system, and you're going to hook up the top pulley system to the horizontal support. And you're basically going to set it up like this last setup, except you're going to keep going. So you tie the string to the bottom pulley of the top pulley system, and then you wrap it like this. Okay, so what we're going to be thinking about here is the work input. And the work input is going to be equal to the force that you exert times the distance that you pull. The work output is going to be equal to the weight of the thing that you're lifting times the distance that you lift it. So there's actually four things that you're measuring here. You're measuring the weight of the masses. You're measuring the distance that the masses are lifted by the pulley system. You're measuring the force that you're putting in. And you're measuring the distance that you exert that force.
I start pulling with my thumb at 90 centimeters. The mass is at 50 centimeters. I need to lift the mass 20 centimeters. I pull until the mass is lifted from 50 to 70 centimeters. That's a total of 20 centimeters. How far did I pull down? Remember, my hand was at 90 when I started, and now it's nearly to 10.
Okay, then the second part of the lab, if you turn the page and look at page 31 where it says Part 2, I'm going to ask you to determine the efficiency of an inclined plane. We had a problem set question like this yesterday. I have inclined planes around the room. You're going to use the same force probes. You will have to reset the force probe to a higher force.
So the purpose of part 2 of the lab is to find out the efficiency in moving a block from the bottom to the top of the ramp. We need to find out how much work it would take to lift the block a certain distance. And the distance I'm interested in goes from the table to the bottom of the ramp at the end of the block. Think about why that measurement makes sense. Now, to figure out my work input, I'm going to need to measure the distance that I drag the block. I'm going to measure from the end of the ramp to the end of the block to determine how far I pulled the block. Remember to pull the block with the force probe at a constant velocity, and the calculator will read the force for you. Here I'm setting up the calculator, set up probes, pressing number 1. Battery is low, I'll ignore that. I've got 1 probe, press number 1. Battery is low, I'll ignore that. I've got a force probe, number 2. I want dual range 50 newtons, that's number 4. And make sure that the force probe is also set to 50 newtons. I'm going to use my stored calibration, go back to collecting data, and I'm going to do a monitor graph or monitor input. And it'll read the force that I'm pulling with in real time. So right now I'm pulling with 10.507 newtons of force.